Okay, now, here's the assignment today. Write a polynomial function with the given roots. Only real rational roots. That means no i's, no square roots. Okay? Now, you will have to fix i's and square roots. Write a polynomial function with the given roots. Only real rational roots. No I, no square root. Well, this first one's easy. We have two roots, so that means I write y equals and I make two parentheses. There's no i's, no square roots there, so that makes for an easy problem. You always put x minus, you start it that way. Then you just put 7 and 10, and that's it. You don't need to multiply it out. Now, game changer on the next one. You're actually going to make 3 parentheses, and here's why. -3 is a root. And 5i is a root. Well, if you have positive 5i as a root, then negative 5i is also a root. Okay? They won't tell you that, but when you have an I, a complex root, an imaginary root, whatever you want to call it, you have the negative and the positive. So you're going to make 3 parentheses. So, x minus, x minus, x minus. Now, if you put -3, that actually goes to +3. -5i goes to +5i, and then 5i. Now, this is okay, but this is not, okay? The x plus 3 is fine, but I do not want to see i's or square roots in the answer. Here's what you need to do. You need to circle that, circle them together, and you need to do a FOIL, okay? So, x times x, x times -5i, 5i times x, and 5i times -5i. So x second is x times x second. Then I put -5 and then ix. Some of you are like, well, I've never seen that before. Well, there's a reason you don't. And then you'd write 5ix. Well, these are negative and positive of the same thing, so they cancel. Really, it's even a waste of time. When you have the same thing, but one's positive, one's negative, it's a waste of time to even do that. You can just take x times x and then 5i times -5i, because those are conjugates, CJ. So anytime you have CJs, you can just multiply the first and the last. Okay, now 5 times -5 is -25i to the second, but I to the second actually has a number value of -1. So that makes 25. So this becomes x to the second plus 25. And now you can write your answer, okay? X to the second plus 25. Alright, got plenty of examples here. Next one, you just see -10i, just one root. Well, you'd also have 10i, so that's 2. X minus, x minus. Then you put 10i, and then this would shift to plus 10i. Now, I don't want to see i's in the final answer, so if you do, you need to circle those, put CJ, those are conjugates, and you need to multiply them out, okay? Remember, these are conjugates, so really, I can just take x times x, and then -10i times +10i, because those middle two cancel every time you're multiplying conjugates. So that's x second, and this would be -100 I to the second. Well, I to the second's -1, and that equals +100, okay? So this is x squared plus 100, and that's what you put. Answer, okay? Okay, now the next one. Again, you can't have the negative without the positive on the I. Also, that rule applies for irrational square roots. See, you can't have a square root of 10 without a negative square root of 10, okay? So you're going to write out 4 of these, 4 parentheses. So that rule applies for i's and it applies for irrational square roots. So x minus, x minus, x minus, x minus. So 2i plus 2i plus the square root of 10 minus the square root of 10. Now, again, you will have to multiply that. And I also, remember I said no irrational square roots. You have to multiply that. So those are conjugates, and so are these. Now I will show you how to multiply that, but we should know how to multiply this from the previous problems. So I take x times x, and then negative 2i times 2i. Again, I proved on the first problem that the middle 2 is a waste of time. So it'd be negative 4i to the second, and that's negative 1, which is 4. So this is now x to the second plus 4. Really, to be honest with you, it'll just be x to the second, then a plus, and you can just take 2 times 2. It's that quick if you want to do it that way. You can remember that. X second, and then always a plus, then 2 times 2 is 4, and then the i's would drop. You can see how that happens. Okay, now I also need to multiply this. I take x times x, then I take square root of 10 times negative square root of 10. Now you're like, how do you do that? I'm about to show you. You got x second. A positive times a negative is a negative. Okay, so you need to put a negative because you're taking a positive times a negative. Then this 10 times 10 is 100. But 100 is a perfect square, okay? It's 10. So that's what you're going to have. You're going to have x squared minus 10. So now you're ready to put your answers. You'd only have 2 of them, though. You'd have x to the second plus 4, and then x to the second minus 10. Okay, we've got 4 more. Negative 6i and the square root of 2. So there's an I, so you got to have the conjugate. A irrational square root, got to have the conjugate. So that's 4 roots you actually have. They're only going to tell you 2. You should know then to find the other 2. X minus, x minus, x minus, x minus. So 6i, then switch that to plus 6i. Plus square root of 2, and it doesn't really matter which one's minus, which one's plus. It doesn't matter. Well, these are conjugates, so you need to multiply them. These are conjugates, you need to multiply them. CJ stands for conjugates. Okay, so I take x times x, and negative 6i times positive 6i, which is x to the second, and then negative 36i to the second. But I to the second is negative 1, okay? So that's 36. Positive 36, so this is x squared plus 36. Now how about the other conjugate, okay? X times x, and then square root of 2 times negative square root of 2. So that's x second. This would be negative because a positive times a negative always makes a negative. Square root, 2 times 2 is 4. But the square root of 4 equals the integer 2. So this is actually negative 2. So you get x squared minus 2. Now, could I get that answer a little quicker? Yeah. X squared, i's will result in a plus every time, and you can just take the 6 times the 6. This would be x squared. Square roots will be a minus, okay? And then you can just take the square roots off those numbers, okay? All right, next one. 4, does that have an I? No. Is it in a square root? No. So, just don't put negative 4. Doesn't have a conjugate partner. Does that have an I? No. Does that have a square root? No. It doesn't have a conjugate partner. Does that have an I? You bet. So its conjugate partner is also in there. So that's 4 roots. X minus, X minus, X minus, X minus. So you're going to have 4, and then 6, and then positive 3i and 3i. Now, these are already set, okay? You don't have to multiply those. But those i's need to go away. So circle that. You got to apply the conjugate multiplication method. X times x and 3i times negative 3i. So it'll be x second, negative 9i to the second, but the I to the second makes us take negative 9 times negative 1, which is 9. So that's x to the second plus 9. That's what they mean by write a polynomial with only real rational roots. They don't want to see the i's. They don't want to see the square roots. There you go. Okay, next one. Does that have an I? No. Does it have a square root? No, so it won't have a conjugate. Does that have an I? No. Does it have a square root? No, doesn't have a conjugate. Does that have an I? No. Does it have a square root? Yes, so it has a conjugate. It's opposite. So it's 4 roots. So x minus, x minus, x minus, x minus. So we'll just put plus 2 because of negative 2, then plus 3. Then one of them has a square root of 5, one of them has positive square root of 5. Doesn't matter which one's minus, which one's plus. Now these ones without conjugates, they just drop down. But this one with a conjugate, we have to make that into one single parentheses without the square roots, okay? So I take x times x, and then I take negative square root 5 times positive square root 5. X to the second, negative times positive is a negative. And then you multiply the 5s to get 25, but the square root of 25 equals integer 5. Integer means that goes away. And you have x to the second minus 5, okay? Boom. Okay. Now get ready for the next one. I'm going to write way over here because this is going to be a long one. Does that have an I? Yes. So its conjugate partner comes in. Does that have an I? Yes. And the reason why you have to put its partner, because anytime we've got answers for I, it has that solution and then the other one's its opposite. You never solve an equation and get just a 2i without a negative 2i. It doesn't happen. Because if the I comes in, you don't write this, but because if you have to square root, you make that positive I. Square root of 4 is 2, but a square root's a positive or a negative. So the answers are 2i and negative 2i. That's why you cannot have that, okay? And the same with the square roots. If I have x squared equals 3, you can't simplify that square root, okay? It would be just plus or minus, and the square root would stay on the 3. So that's positive square root of 3 and negative square root of 3. So that's why when I see i's and square roots, the opposite is also an answer. So like that one, square root of 6. So negative square root of 6 would come in. So that's 6 we have to make out. Now it's only going to end up with 3 because they're all going to have conjugates. So x minus, x minus, x minus, x minus, x minus, x minus. So 2i plus 2i plus 5i, and then 5. It doesn't matter which one's minus, which one's plus. Then plus square root 6 minus square root of 6. Now I'm writing really small here because we have to multiply our I conjugates in the square roots. So those are only going to end up with 3 parentheses. Now, there is a quick way to do this, okay? And I will show it on, I'll do the long way this way, but then I'll show you how you can do the i's quickly, okay? So I take x times x, and then negative 2i times 2i. So we know that's x to the second. We know that's negative 4i to the second, but I to the second holds a negative 1 value, and that ends up being 4. So that would be x squared plus 4. Now, let's do this one a little quicker. X times x is x squared, right? The i's will always result in a plus, and it'll be just 5 times 5, which is 25. That's a quick way to do it. Now, let's do the square roots. So I'll do it the long way. Then square root of 6 times negative. Remember, one's positive and one is negative, so it's x to the second. Negative. 6 times 6 is 36, but the square root of 36 equals integer 6. That means just negative 6. So it'd be x squared minus 6. Now, here's how that could be done quickly. Okay, I'll show you how to do a square root one. So i's, I said x squared plus, and then just multiply the numbers. Now, to do conjugate square roots quicker, but you have to really understand it. X squared, and it wouldn't be a plus, it would be a minus. And then the square roots would just come off the 2's and you'd get 2. Okay? Again, if I'll do another one, because it goes that quick, I'm just making these up. So x squared minus, and then be just 7. Okay? Because it always works out that way. I've shown you the long route how.